Hi, my name is Tim. Join me in this video as we go through RC telemetry for newbies. Let's get to it. So I'm with my good friend and colleague Ron in his workshop, and we're going to go over telemetry for RC model aircraft. So we're very pleased to have you help us out, Ron. Ron is an electronics engineer. His day job is satellite communication. So if anybody's qualified to do this, as you can see, he's basically a master builder. So he's going to take us step by step with an introduction on RC telemetry, and I'm going to be learning along with you. Please, if we're missing anything or if you have any questions, don't hesitate to put them in the comments. We can make a follow-up video answering your comments. So with that, Ron, we look forward to, you've got the mic.
Okay. Okay, well, thank you for the introduction, Tim, and I'm really glad to be able to help you. I'd like to start off by just explaining to anybody who doesn't understand what is telemetry. We're all familiar in the RC world with having a transmitter where what we do with this is we tell the aircraft what we want it to do. So we use the transmitter to send commands up to the aircraft. Telemetry is when the aircraft is actually sending information back to the transmitter. And if you think about in the full-scale world, with a new aircraft, when the test pilot takes it up, if things are not going well, then the test pilot is extremely busy trying to keep the aircraft together and hopefully get safely back on the ground. If things do not go well, then he leaves the aircraft and hopefully survives, and of course the aircraft crashes. First thing people want to know is what happened, and a flight recorder may not have the necessary information. It's much better if the aircraft can be gathering information during the flight, sending it down to the ground controllers, and they can be looking at that as the pilot's flying, and hopefully if they see something going wrong, alert the pilot and tell him what he needs to do, come back, land immediately, you have a potential problem, stuff like that. That kind of technology and capability now exists in the model world, which is what telemetry is all about. And you might think, why would I want that? Why would I use it? To some extent, some of us, like myself included, it's just fun playing with the technology. But the reason I got into it was as I moved from typical aircraft like this size, which is a typical 60-inch wingspan aircraft that most of us fly. When you move into the larger aircraft, I had particular difficulty when it was coming to landing them, because when the aircraft was flying towards me and on the approach, I couldn't tell how fast it was going. So I was really worried about stalling it and crashing the aircraft by doing something foolish. And it occurred to me, wouldn't it be great if I had a way to measure the airspeed? Then I could set up a stall warning. So that was what started with it. And if I move from it, this one actually has an airspeed sensor on it, which is right here. We can look at that in a bit more detail later, but that allowed me to fly the aircraft, deliberately stall it at a high altitude, and then after the flight, look at that information and say, in the case of this one here, hey, this aircraft stalls right at approximately 27 miles an hour. So knowing that 27 miles an hour is my critical speed, I could set a warning at usually go about 5 miles an hour above that. So in this case, 32 miles an hour, and it will begin to alert me that you're getting close to the stall condition. I now do that on most of my aircraft, and it really helps. Then from there, began to move into using other things. I typically monitor temperature, RPM. For anyone who's, I'm a glow engine guy, as you can see here, but for people with an electric aircraft, then critical thing is flight battery voltage. And so you can, when you buy a telemetry capable receiver, there's a little plug with 2 wires comes with it. You connect that to your flight battery and it will send the battery voltage back to your transmitter in real time. You can set up a warning on that. Now, what do I do with the information, all the stuff that I gather? I do a number of things. Some of it is just pure interest, post-flight analysis. You know, as I was making a turn, how well was I doing trying to keep it a level turn? Was I losing altitude, gaining altitude, all that kind of thing? When I'm coming into land, am I maintaining a steady airspeed, steady approach speed, or am I all over the place? And sometimes the answer I get from the telemetry information is I wasn't flying nearly as well as I thought I was. So it helps develop flight capability. Obviously, we all unfortunately do crash sometimes. When I crash, I'm able to then have the telemetry information. I'll explain later in a few minutes how I get that. Have the telemetry information that I can do a post-crash analysis and say, what did I do wrong? Because my experience has been that every time I thought something broke, or you know, you hear people talking about tip stalls or a bad servo or losing link and things. In my case, every time the problem has turned out to be a problem between my ears, it was always my fault. And but without the telemetry information, I could have made all kinds of excuses. Now I know what I did wrong. Did I build it wrong? Is my battery insufficient for the servo load? All that kind of thing. Then, of course, there's the preventative stuff, stall warning being an example. When there's multiple aircraft flying around, even with a glow or a gas engine, if the engine quits on you for some reason, sometimes you don't know because of the noise of all the other aircraft. Now, with an RPM warning, I will know immediately if my engine quit and know that I've got to try and glide in and land as soon as possible. I have a temperature sensor, so if I've got insufficient cooling, haven't made a big enough opening in my engine cowl, I'll see the temperature rising, get a warning about that. I know to slow down, come in, land. Mentioned low voltage warnings, and there's a multitude of things. Really, it's a case of how much complexity do you want to add, and I completely admit a lot of it's just for fun. But a lot of it is extremely useful. It really has helped me a lot. So one of the first things that people considering moving into telemetry, or if they've made the decision and they want to start, is what kind of equipment do you need? And of course, first to mind is, do I need a super expensive fancy transmitter? I happen to be fortunate enough that I have one that's top of the line Spectrum, but the software is common, all Airware to all Spectrum transmitters. Now I should mention, everything that I'm about to talk about today is Spectrum focused because that's my knowledge area, but all the typical RC equipment manufacturers like Futaba, FreeSky, all those, they all have equivalent equipment. It basically works in the same way, although they might use slightly different names for copyright reasons or whatever. So whatever Spectrum transmitter you have, I don't know about the really low end, but it's certainly all the newer ones like the NXs and the IX series are all telemetry capable. And what will happen there is that in addition to the information coming back from the aircraft, the transmitter itself, if you are logging the information, which is a setting you set in the transmitter, so that whenever you're talking to the aircraft, what you will see when it's active, it's not on right now, but up in the top left area, right up here, when I start the aircraft up and activate this, I will show you there'll be the letters SD, which is historic from when removable disk cards were used, the SD cards. So what the transmitter is doing is, while it's receiving information from the aircraft, and I'll demonstrate this to you in a few moments, it can actually be logging what it's receiving from the aircraft into memory. When it's doing that, up in this area here, there will be the letters SD, which is historical from the earlier spectrum transmitters that used removable SD microcards. And they still use the letters SD just for commonality. And you'll see little dots moving underneath that tells you the logging is active. Now, what's particularly useful in the way Spectrum does it is that they not only log all the information coming back from the aircraft at about, I think it's around 50 times per second that they do that. They also log the position of every switch, every control lever, the sliders, everything, every input that you might be making is also logged at the same time. So you can tell if you were telling the aircraft to climb, to roll to the right or whatever, and where your throttle position was, all that stuff is being logged into memory. Now, that's on the transmitter side. Of course, and point is that you do not need a high-end IX transmitter, an NX, and I believe most of the later model DXs will also do the same thing. I'll just turn that volume down for now. Of course, the other end of the situation is, what do you need in the aircraft? What type of receiver do you need? Now, most of the current receivers that Spectrum makes will have a T at the end of the part number. What that T means is it's telemetry capable. So for the older ones, if you have a receiver that was prior to that, it's very easy to upgrade it to telemetry capability. You can either, there's a module you can buy, it's called a TM1000, which they made for a long time. I think this may be discontinued now, but there's still tons of them on eBay and RC groups and places like that. And this connects to your existing receiver, and bingo, you have telemetry capability. And with different capability in here, there's sensors that connect directly. There's also a serial bus that connects to all kinds of other sensors. If you want there's another way you can do it. If I reach over here, where this is a Spectrum remote receiver, and this, you can buy a remote receiver that's telemetry capable. So by replacing your existing remote or adding an additional remote like this, suddenly you have telemetry capability. So it's not difficult to do. Yes, it's an extra part you have to buy, but they're not super expensive. So very easy to upgrade and give yourself telemetry capability. The newer receivers also have some of the sensors built in now. So depending what generation your receiver is, there's many of the sensors you don't need to buy anymore. And the basic capability you'll get with your receiver is it will give you the capability to measure, it will tell you the receiver voltage. So if you have a separate receiver battery, you're getting that battery voltage. So you'll be able to see if your servos are dragging the voltage down and causing a brownout on your receiver. You will be able to see which satellites are receiving signal and how well they're receiving. So you know if you have an antenna position problem in the aircraft. You will be able to measure temperature and RPM directly with most of them. And the newer ones even now have the built-in variometer sensor. You no longer need to buy the modules that I use. It's actually built into the receiver. And what that gives you is aircraft altitude. So you can set to make sure you don't violate the AMA 400-foot limit thing. It also gives you Vario, which is really aimed at sailplanes, at gliders, but for non-sailplane aircraft, it gives you a vertical airspeed. You basically have a VSI, so you can measure on your approach what your descent rate is, what your climb out rate is, all kinds of fun things you can look at if it's of interest. Okay, so I've now started the aircraft up so you can see some things going on. And if I first of all, I have mine set so that if I activate throttle hold, where it'd be carrying the aircraft out to the runway for takeoff, so you don't want anything bad to happen if you bump the throttle. When I disarm that, so the aircraft's now live, you see immediately the it's now logging information. So that's the logging information that I was mentioning. I've seen a lot of questions on RC groups of people saying, I see this little SD thing with a dot moving underneath. Why is it? That didn't happen before. It's because Spectrum updated their software to be telemetry compatible across all transmitters. Now, if we look here, is an example of information that you can see in this case, and this is all configurable. This is just how I have it set up. In this case, we have airspeed, we have receiver voltage, we have engine temperature, engine RPM, which that's because I've wiggled the thing just to make it, you can see it do something if I'm just wiggling stuff to artificially pretend the engine was running. My timer, flying timer, and my altitude. So if I lifted the aircraft up, you would see that go up to 2 or 3 feet. On the IX radios, I don't know about the others, but there's also some well, basic telemetry first. I'll get to the IX in a moment. You see for the different satellites, if there's any fades or any losses, they get logged here, so you can see which satellite is losing signal. If you get any frame losses, which is, I believe, 45 consecutive fades across all on a channel, then they're logged there. And the hold is if you lose all signal for a certain period of time. So holds are really bad. That's where you really did lose contact with the aircraft. That's very unusual, but it gets logged if it does happen. You then have not only your instantaneous basic information of voltage, RPM, and temperature, but you also, it logs for the entire flight the minimum and maximum values. So you can tell what was the maximum height you got to, what was the maximum speed you went at, all those kind of things, and the minimum too. Then on the IX specific information, that's just my lost aircraft alarm. It's got a timer on it, so I've got to wiggle things occasionally. On the IX radios, you can configure things to be like dials. So an example of that, if I lay this where my cinematographer can look at this one, you'll see if I blow into the airspeed sensor, you'll see the airspeed going up. You should have. You see anything there? Yep, good. So you could. I don't find this particularly useful other than on the ground. I find it useful when I'm tuning the engine, setting things up, but I never look at the display while I'm flying, so they're kind of geeky, fun things that is not particularly useful. But to get this type of information, what do you need in the aircraft? The first thing is for airspeed, this one right here, and this is an option. It's not baseline, this is an option. And to do that, you need one of these things, which is a sensor you buy from Spectrum, and it has the pitot tube, the pitot-static tube, and then it has the connecting pipes, just a little flexible pipe, and the sensor that you can see right here. So it's pretty small, really lightweight, and then the serial bus where you can daisy chain multiple sensors. You just connect them all together and it plugs into one place on the receiver, and it sorts out all the information. That gives you airspeed. If you want altitude and variometer, and you don't have one of the latest receivers, then you need sensor like this. So I have in the wing of my aircraft, I actually usually put it close to where the aileron servo hatch is, so it's accessible for maintenance. One of these sensors and one of these daisy chained inside the wing, then it comes back into the receiver. If you buy one of the newer receivers, like this is an AR-10-100, then, and it doesn't need to be a 10-channel receiver. The newer ones have this sensor already built into the receiver, so it comes at no additional charge. It's built in there, but it still has the connectors for all the other external stuff that we might mention. And all the receivers come with this little cable, which is a plug with 2 wires. That's to connect to your flight battery if you want to add that if you have an electric aircraft. The other stuff that I put typically in my aircraft is engine temperature, which is this little red thing here, and the wires are these 2 little black ones. Then on the other side, around at the back here, you will see here, which is a magnetic sensor that senses the movement of the crankshaft of the engine for RPM measurement. Gas engines, I believe you can monitor from the electronic ignition on those. There's an output that can connect to telemetry, but I don't fly gas, so I can't speak authoritatively on that. Inside the aircraft, then what you have, the sensors that were in the wing come in. There's a serial bus right here, and they connect directly to the receiver, which is right here. The other sensors like temperature, RPM, anything else you might have, either come in through the serial bus or plug directly into the receiver. So it's really a very, very simple addition to the aircraft to add all this stuff. And then it's down to what information do you want, how do you want to use it, and that's obviously entirely up to the user. Now, when you have all that information, then it's a case of, okay, I get this log file with all these, it's logging information at roughly, I believe it's about 50 times per second, so about every 20 milliseconds it logs the information, and it goes into a memory file. So we'll turn this off right now just so we don't set alarms off. I'll give you a quick look at an example of a log from a flight from this aircraft. Actually, I log every flight that I make, and it's just, but that's just me. Okay, so we've spoken up to this point about things that may be confusing to some people, gathering information into what I've referred to as a log file. That's similar to your model file in your computer, your transmitter memory, which would be an SPM or an ISPM file. For the logging, it's a TLM file, so the file name ends .tlm, which is telemetry file. Now, you obviously have to get that file from your transmitter, your radio, into your computer to analyze it and do things with it. Depending on what transmitter you have, the file will either be stored on a removable SD card, in which case you pull that card out of your transmitter, plug it into your computer and read the file. If you have one of the newer Wi-Fi capable transmitters, you can either transfer the file using Wi-Fi or Bluetooth or a USB cable. There's multiple ways to get it from one to the other. Once you've done it once or twice, it's very easy. Now, when you get the information into the computer, one of the things that you need to know is that you will need to download an application called TLM Viewer. It's a third-party piece of software. It's free of charge to download. Spectrum does it that way because the updates to software and to computer interfaces is so frequent that there's this little third-party outfit that does it all for them. They're super responsive. If there's an RC Group's site for that, and I've seen people send questions to their head software guy saying, hey, I wish we could read this way, or I think this might be a bug. He usually responds within 24 hours, sometimes same day, with an update or a fix or an explanation that they're misinterpreting the information. It's really, really good. So don't be afraid of that. That's not a problem, again, once you've used it once or twice. Now, I've got an example on here, which is a log file from one of the flights on the spacewalker there. And if I show you here how we do it, what the typical TLM file looks like. I'll take the graph off for a moment. We'll come back to that. But it starts off when you'll have this log file, which in this case I always to use different file names. So the file name is which aircraft it was, followed by the date of the flight. So this one happened to be May 28 of 2022. So when you open up the file, you get a number of standard tabs, and it depends on what sensor you have fitted. But for standard telemetry, you always get RPM if you're measuring that, temperature, the receiver voltage, and the primary receiver signal levels in dBm, and this if it goes on and on and on, because as you can see, it's every 6 to 13 is what about 7 milliseconds. So it's logging very, very frequently. It goes on all the way down. You have the timestamp here. So this total log is 6 minutes and almost 49 seconds long, and gives you everything you might want to know. Now, in addition to the standard stuff, there's what comes through the receiver for the satellite signal levels, any frame losses, any holds, and what the instantaneous voltage to the receiver was. So if there's ever a dropout where you have a brownout, you can search this file and find it if you want to. That's if you want to do it by data. Similar things for the variometer sensor, where you've got the altitude and the climb/descent rate. If I widen that, you'll see it's climb rate in feet per second. Now, radio input is an interesting one, because this is a huge file where it gives you for every switch on the transmitter and every slider or lever there, then it's telling you its position, again logged at the same speed. So there's a wealth of information here. Now, nobody wants to go through tables of numbers. That's monotonous and very difficult to find what you want. So what this software allows is you can go up to the top right here and click Graph Data, and then you select what do I want to look at. So in this case, I've selected airspeed, engine RPM, and I also selected altitude. So I know how fast was the aircraft going, how high is it, and what speed was the engine running at. But you can see I can choose to look at anything that's available in the log file. Now, when you go OK, then it will draw the graph for you. And there's little tools on here you can zoom in. This portion that I'm looking at is when I was landing the aircraft. So this trace here is the altitude. So you see I did a couple of low passes down the runway, then I came in and landed. When I was coming in to land, then you can see what the engine was doing. So you see me slowing down to descend and then throttling back up to climb out, go around again. Then this time I throttle down and I hold it there while I'm descending to land. And you see this one, which is hard to see there. You see the airspeed. Now, if we look at going a bit closer and look at just the landing portion, then we'll see right here. And what you see is, here I am descending down, and then wheels actually touch right around here. When I actually touch, my speed was about 32 miles per hour. You can see it right there. So I landed at approximately 32 miles per hour. And the thing that's interesting here, this is, I kind of chose a nice one to show that I'm not as bad a pilot as I really am. So this is showing that the airspeed was relatively constant during the descent. It was all floating in about the 40 miles per hour range as I descended on final. And you see the RPM on the engine is relatively constant. I don't really throttle back until just before touchdown. As I go into the flare, I move back to full idle, and you see the airspeed drop dramatically after the wheels touch and the aircraft goes through the rollout until it comes to a complete stop. So you can look at this, and this shows, was my speed constant, was my throttle management reasonable, and was my altitude descent, was it a reasonable descent, or was I climbing, descending, bobbing up and down? What was I doing? So that's just one example of how you can take all this complicated table of information and turn it into something that's meaningful to a human being that you can actually do something with. Now from that, it's a case of the world's open to you to, as you come up with other questions, you look at the information in a different way, or you gather different information. It's really up to you. There's no end of the possibilities. I found it great. I play with it all the time now, which is why I log every flight that I make.
So Ron, thank you very much for this overview. It was a wonderful overview, and we'll look forward to studying it. And again, any questions you have, just put them in the comments. We'll look forward to making a follow-up video. Thank you.